what we did yesterday is we just factored. That's all we did, right? The reason we had to factor is because we might find holes in graphs. Okay, Shani? Okay. All right, so let's practice this. We're on page 53. Let's go practice how we'd find any of these holes or vertical asymptotes. These are all I want to focus on right now. Oh, not horizontal asymptotes, vertical asymptotes and holes. Okay, for us to have a hole, it says whenever you've got a common factor in the numerator and denominator, that's called a hole. Now let me tell you, what the heck? What are we even talking about? Let me give you an example. If when you factored something, we had, say, x plus 5 times x minus 2 over x minus 2 times x plus 7. Let's say that we factored something to look like that. Do we have a common factor, meaning the same thing in parentheses in the top and the bottom? Shall we do? Do you agree we got an x minus 2 in the top and the bottom? Guess where our hole is going to be? Yes. The hole is going to be where this equals 0. So it's always going to be kind of that opposite thingy again. It's going to be when x is 2. Cool? Guys, then what do I have left? I apologize I didn't leave you more room up there. We're going to explore it more with this stuff though, but I just want to show you what would be left of my function if I crossed out my hole, because if those cancel out, what's left? Yeah, x plus 5 over x plus 7. Thank you, Sean. This is what's left. You guys, a vertical asymptote then is where the denominator is 0. Where's my denominator going to be 0? At what? -7. Again, it's the opposite game. So I'd have a hole at 2, and I'd have a vertical asymptote at x's -7. Now, again, you don't really have to write this down for this problem because we're going to practice it a lot. But why wouldn't I have used the info over here to find the vertical asymptote? I would have said 2 as well because I had an x minus 2 over here, but it cancels out. So we got to get rid of the holes before we talk about vertical asymptotes. That was a lot on a little definition. Let's just apply it to a big old problem. We ready, people? Let's just apply it. This guy here, let's go toot or o-toot the top.
Toot.
Toot. Cooper, I agree. We're tooting. Here we go.
I tooted twice.
Oh my gosh. TMI. TMI. What multiplies to be 3 adds to be 4. 3 and 1. Thank you, Annabelle. Multiplies to be 3, adds to be 4. 3 times 1 is 3. 3 plus 1 is 4. We feel good about the top.
Yeah.
What's up, Bubba?
Are we finding a horizontal asymptote too?
No, we're not going to do that today. We're not going to do that till next block day.
That's gross.
It is actually not very fun. Okay, you guys, what about this toot? I'm going to do it in a different color. What multiplies to be -6 on the bottom and adds to be 1?
3 and -2.
3 and -2? Is that what we're saying?
Yes.
3 and -2. Hey, you guys. Does there appear to be a common factor, i.e., do you think we have a hole?
Yes, x plus 3.
Right? Where is that hole going to be when x is what?
3.
-3. Biscuit Baby says -3.
I wasn't.
Here's what I need you to do. I need you to write -3, comma, blank. Do not be filling that in yet. It's always going to be the opposites. You guys, here's what I want us to write. What's my equation now that we got rid of the hole? Thank you so much, Beck. Here's the deal. Now, what's my vertical asymptote? Vertical asymptote, I think, let's write ourselves some reminders. That's when my denominator is 0. Beck, you just said what? 2. It's going to be when that denominator is 0. When is x minus 2 equals 0? When x is 2. You guys, a vertical asymptote, it's important to write it as x equals because a Vux vertical line is always x equals.
Interruption, Aaron.
Here's what I want to do. This is where I'm taking you a little further than my other classes today. This hole. We got to figure out exactly where the hole is located because our calculators are the worst and it's not going to show you the hole. Check this out. I will go type this in, I promise. Biscuit Baby, you do not need to type this in. If I went x squared plus 4x and then plus 3 over x squared plus x minus 6. Do you agree that, I don't know why I have all those little points hanging out on my graphs, but whatever. Do you agree it's not showing me a hole anywhere? But watch when I do zoom decimal. Oh, because my calculator is free, it doesn't show me either. Yours would show you a hole if we did zoom down. Don't worry about it, I promise. Because it's still not going to give you the location. It's not going to tell you what it is because it doesn't exist. Here's how we're going to find the low K. This is my new equation that everything that we're going to talk about next week is based on. Yes. Say it, Cooper.
You put negative 3 in the x.
Boom. You put that x coordinate into my function once I've gotten rid of the hole. If I put it in right here, I'm going to get 0 over 0. So we put it in here. You guys, what's negative 3 plus 2 on the top going to get me?
2 negative fifths.
Negative 2. What about on the bottom? If I put a negative 3 minus 2, it'd get me another negative 5, right? So you're just saying a negative over a negative is a positive 2/5? Agreed. So now we're just going to go, we're going to put just these 2 pieces of info on my picture, you guys. I want to go vertical asymptote is 2. So I'm going to draw a vertical asymptote, and I do that with dashed lines. And then I need to draw a hole at negative 3 up 2/5. You guys, I'm just going to go negative 3 up 2/5. I'm not sure about there. And I'm going to put a hole. On this one, I already factored it. You agree we've got a hole at what x value?
4.
4. Agreed. I've got a hole at 4 something. And then I'm like this. Bye. You're gone forever. And I'm going to write what's left. X plus 1 over an x times an x minus 2. You guys, you could have more than one vertical asymptote. When will this denominator equal 0? It will happen twice. And if you've got 2 of them, maybe you separate them out, or you just might be able to think of it. You separate them each out and you say, when does x equal 0? When does x minus 2 equal 0? I just wrote each of my denominators separately there. And isn't this one already solved for? 0 is one of my vertical asymptotes. And what's my other one back? 2. So we're going to just say my vertical asymptotes are 0 and 2, or x equals 0, x equals 2. You can combine it however you want. Let's go find the coordinate of that hole. If x is 4, I'm not going to plug the 4 in up here. I'm going to plug the 4 in right here. What's 4 plus 1 going to get me on top? 5. What about 4 minus 2 there is going to get me 2 times my 4 over here? 8. So my hole is going to be at 4, 5/8. When we go to graph that, we're going to just estimate. I'm going to go right 4, 1, 2, 3, 4, up 5/8, which is about a halfway. Sure.
We did it.
We're going to go draw those vertical asymptotes too, Coop. We got a vertical asymptote at 0 and a vertical asymptote at 2. We got to O2 this top. So we got OT, OOT. What multiplies to be 8 and adds to be 9? 8 times 1 is 8. 8 plus 1 is 9.
Yep.
Agreed. Thank you, Mr. Ritz. With O2, we bring down the 2x squared. We replace the 9x with an 8x and a 1x. You could put that in either order, 1x and 8x, whichever order you want. Then we go get our magic wand. I'll see you at the end. See if you can O2 that.
Ooh.
Are we okay with our O2? We feel good about the top? Are you cool with saying the top O2'd it into that?
Yeah.
The reason I just feel like we can put the toot, we can just put toot right on the bottom. You know what I'm saying? So we don't have to keep writing the same thing. If I were to toot this bottom, what multiplies to be 5 adds to be 6?
5 and 1.
Plus 5 plus 1, plus 5 plus 1. So I got x plus 5, x plus 1. This is my function factored.
And there's no hole.
There's no hole. Does there have to be a hole? There sure does not need to be a hole. Then this one, there doesn't happen to be one. So we would just say hole, none. We love when there's no hole. You know what I'm saying? We don't have to worry about it. How about my vertical asymptotes? When would these denominators equal 0? -1 and -5. X is -1, X is -5. Let's go draw that in my graph. Vertical asymptote at -1 and at -5. Okay, let's take a peek at this next one. What about this guy?
I have a theory.
I don't have to toot or o-toot the top 'cause it's only got 2 terms. Can I do difference of squares on that?
No.
No, but before we even look at difference of squares, take out a GCF every time.
Yes.
What's the GCF out of the top?
4.
4, leaving me with a... Thanks, Kate. Can I difference the squares this now?
No.
Nope, because that's all I've got. That's as far as we can go. We don't have a different minus
Could
sign.
do difference of the squares x to the cube minus 1.
This one would be difference of cubes, which we don't need to talk about this year. So we're going to leave it. Sure, would it be? I'm going to show you why we don't need to worry about it. I'm good with just writing it as x cubed minus 1. I don't need to remind you what difference of cubes is. Because do we have a common factor in the top and bottom? Do we have a whole? No, right? Nothing's canceling out. Vertical asymptote every time, you guys, is just when that denominator is 0.
So 1.
Yes, I was thinking -1 as well, but it's a cubed, right? When does my denominator equal 0? We can just set the denominator equal to 0. Richie's like when we add 1 over, and then I take the cube root of 1. Cube root of 1, you guys, what times itself 3 times is going to get me 1?
Yeah.
1. If it was the cube root of -1, it would be -1. Or if it was a square root of 1, it'd be plus or minus. Very good. So you guys, the only time that denominator is going to be 0 is if that x was 1. Boom.
Therefore, we smart.
We smart, and we're going to just go put that vertical asymptote over at 1, right? Let's just do this last one. We got this, people. We got a factor. Tooting or o-tooting on top? Just toot. What multiplies to be 3 adds to be 4? 3 and 1.
And this is a difference of squares.
This is a difference of squares. It's got 2 terms, doesn't have a GCF. What's the bottom going to factor into?
2x minus 3.
And then?
2x plus 3.
Good. I just always put my plus 1 first because you know me, I like to say Plinus. Guys, any hole on this one?
Nope.
I really strayed away from the holes, didn't I?
Yeah.
And that's okay. How would I find the vertical asymptotes on this guy?
Same thing. Just set equal to 0.
Set them equal to 0, you guys. When does 2x plus 3 equal 0? When does 2x minus 3 equal 0? Love it. He's saying subtract 3 over, divide that by 2, add 3 over, divide by 2. Awesome, Ritzman. We've got 2 vertical asymptotes, and they're at plus or minus 3 halves. What would that be as a decimal? Yeah, so I'm just going to go to my graph, and I'm just going to go to the right 1.5, and I'm going to draw a dotted line, and I'm going to go to the left 1.5.
And we're done.
And we did it. So now, if you flip to your pages 55 and 56, you've already factored them all. You've already factored them. Biscuit, do you mind telling me what 4 factored into? What was our 4?
Negative, sorry, x minus 2, and then x plus 3.
Love it. What about on the bottom?
That'd be like -4, like at the start.
Yep.
X plus 3, and then x plus 1.
Okay, so here's what I want to do with you guys real fast. Ready? On number 4, let's look at 4 together. We all should have gotten this far. Is there a hole?
Yes.
Where?
3. Negative 3.
At -3. So we're going to say hole, -3, blank. Then I want you to write what's left. When I say write what's left, I'm like, all right, my function is now x minus 2 over a -4, x plus 1. This now is what dictates everything else. My vertical asymptote, asymptote is when the denominator is 0. Is -4 ever going to equal 0? We don't have to worry about it. Is x plus 1 ever going to equal 0? Yeah, at what? Beautiful. And then I'm going to say negative 4 never even equals 0. I don't have to worry about that. I only have one vertical asymptote. I didn't give you graphs or anything today. All I'm looking for is for you to find this value and this whole value as well. If the whole is at when x is negative 3, we got to go plug it in to see where that y is going to happen. What would happen up top? Negative 3 minus 2 would get me negative 5 up top. Negative 3 plus 1 is negative 2.
It's
Times negative 4
5/8.
is negative 8. So I'd have a negative 5 over a negative 8. So I agree I'd want to simplify that to be a positive 8. I'm sorry, positive 5/8. And that's all I'm looking for today. So I just want you to go through. You've already, in my opinion, have done the hard work of factoring it. So let's go find the holes in vertical asymptotes. And
Positive 5/8 or negative 5/8?
it'd be positive, wouldn't it?
Negative 5.
My bad. Let's see. You were saying if x was negative 3, it'd be a negative on top, right?
And then it'd be negative 2 times a negative.
Oh, right. A negative 2 times negative 8 is a positive 8. So you're saying my final answer would be a negative 5/8.
Why?
Guys, thank you. I'll help you, Cooper. We both had the same.
Oh, because negative 4?
Yep. Good call. So my answers are right up here.
We're doing 55.
Yeah, you're going to do 55 and 56 of just finding the vertical asymptotes and the holes. That's it.